Good morning, everyone. Today we are going to talk about our sea and air experience. Emerging pollutants (AP) are defined as chemical, synthetic, or natural materials that are not commonly monitored in the environment, but which have the potential to enter the environment and cause known or suspected adverse effects on the surrounding environment and human health. They include a range of organic chemicals such as pesticides, agricultural products, and pharmaceuticals. These pollutants are passing through rivers, lakes, or streams and then flow into the waters commonly used by man. For this reason, methods have been studied for the success of their elimination. Many of these pollutants have maximum values established in Legislative Decree 18/2023. Let's talk about removal techniques. The term membrane separation processes refers to all technologies in which the separation and concentration of one or more substances is achieved through the use of membranes. Membrane separations are innovative technologies that allow to enhance and recycle industrial waste substances and promote the development of products with high added value. In particular, we can have microfiltration, used to separate high molecular weight compounds from low molecular weight compounds, or to remove solid particles from the solution in which they are present, ultrafiltration, nanofiltration, and reverse osmosis, a membrane operation that allows to separate solids of different types from the solvent in which they are present. Let's talk about nanofiltration. Nanofiltration is a process used to remove very small molecules or ions from highly dilute solutions. NF finds application in the removal of contaminants from water, such as pesticides, heavy metals, and dyes. With regard to the removal of dyes from water, at the sea and air we use graphene. Graphene plays a key role in the production of innovative membranes for water purification and desalination. It is used for its chemical physical properties. In fact, it has a high specific surface area, it is conductive, and can be chemically modified to remove specific pollutants. From the image, we can see two test tubes filled with water colored with rhodamine, a dye used in histology. The aim was to remove the rhodamine from the water. The first test tube was treated with activated carbon, a substance also used for the removal of solids, metals in the water, but as we can see, it cannot remove the rhodamine. The removal occurs instead in the second tube, in which the water has been treated with graphene.
Ultrafiltration is a membrane separation process also based on the molecular sieving mechanism of solutes of interest. UF differs from nanofiltration due to the smaller dimensions of the retained solutes and the pores of membrane used. They mainly made up of organic polymers, have a thickness between 100 and 150 microns, and separate molecules of the order of hundreds of Daltons, preventing the passage of macromolecules and particles larger than 0.001 micron. The material most used in the construction of UF membranes are cellulose acetate, now obsolete, polyvinyl difluoride, polysulfone, and ceramic. Ultrafiltration is generally used to separate high molecular weight compounds such as protein, polysaccharides, and colloidal particles from low-weight molecules. Some application examples are recovery of proteins from way of aqueous solution, recovery of antibiotics for fermentation broth, and recovery of compounds useful in agro-food field from wastewater. At the CNR, we actually use polysulfone membranes to filter milk. Polysulfone is a highly robust thermoplastic material. It is used, as well as for construction of UF membranes, as dielectric incapacitors and in the production of baby bottles and food containers thanks to its non-toxicity. We made a polysulfone membrane by making a strip of industrial compound of the polymer, which is in the form of a viscous liquid, on a special plastic film, and we distributed it uniformly on it using an applicator knife. after which we immersed the film with the polysulfone on it in the water, and we waited for the polymer to have the consistency of a jelly, and we remove it from the water by removing it from the film at the same time. We used small pieces of polysulfone to create a filter for the removal of rhodamine from the water. In particular, we inserted a piece of cotton into the bottom of a cylinder, filled it with bits of polysulfone, and pressed it together. At the bottom of the cylinder, we connected a tap from which the liquid will come out. We poured the water containing rhodamine and opened the tap to start the filtration. At the end of the process, the rhodamine was retained by the polysulfone, and the water we collected was therefore colorless.